At SpaceClaim, we help our customers leverage the power of 3D modeling to win more business. Across industries, including automotive, aerospace, and defense and electronics, we're seeing sales and business development teams improve their win rates and close deals faster by putting 3D in the hands of their sales teams and customer-facing engineers. Today we'll look at how we can use SpaceClaim to reduce cost, size, and weight in a design. SpaceClaim is a tool that lets you quickly design and model things in 3D. And Pull does all of our geometry creation, allowing you to dynamically change models or precisely dimension them to different heights. Today we'll be looking at an RFP for an electronics box. One of our customers needs a custom device that will fit under that seat. As is often the case, the performance requirements are similar to one of our standard products, but we'll have to do some customization to meet the specifications laid out for us. In SpaceClaim, it's easy to bring in customers' data and use it in your own design. We can bring in geometry from STEP, IGES, Parasolid, ASYS, and all of the major CAD systems. Here we can take in our old board and line it up into place simply by moving the geometry to a new location. We can use Move to translate or rotate geometry on screen. With our simple UI, it's very easy for even casual users to get a great benefit out of 3D modeling. Simply selecting what you want to change and edit it, moving the geometry dynamically, or snapping it up to other elements of the design. And here we can see we already have a problem with our circuit board sticking out of the back. Let's see what other problems might arise after making a change to the height of our old box. We'll just select on what we want to change and move it into place. Now you'll notice that I'm moving not only the top of our box, but also some of our power supply components in the front. And that's going to cause a problem because we don't actually create these components in-house. So what I'll want to do is create a quick little mock-up of some of the changes we've made so I can make a request to some of our other vendors. Simply select on what we want to dimension and add some intelligence to our design. We can see that the width has stayed the same. We have a new height we'll need. After sending out some of the dimensions to our vendors, a lot of times they'll send back a 3D model. Here I'll bring in a Parasolid file and replace our old one with the new one, and it snaps right into place. SpaceClaim easily lets you work with your designs, make copies, and snap them into place. Now we have two of the new designs in our model. But you'll notice that there's no cutout for our new power supplies. One of our other main tools, Combine, lets you simplify this with ease. Simply cut away the area of the interference and remove the extra geometry. In a few quick seconds, we've removed that geometry, and we can see another problem that's been created. We'll need to change our faceplate design slightly, and we can do so by filling in our geometry. And we've already seen our four main tools in SpaceClaim in action: Pull, Move, Fill, Combine. These four simple tools will let you do 95% of all the changes you need in SpaceClaim. And it's our simplified user interface that really allows new users to adopt SpaceClaim very quickly. It looks like we're going to need new boards or somehow rearrange the existing ones. New boards might be price prohibitive, so let's see if we can use what we have. SpaceClaim's tools let you run through many iterations very quickly in your design stage, so we can experiment with different designs and see how they work. By placing our circuit boards vertically, not only will it be easier to run air across them, but it will also be easier for assembling and replacements later on down the road. In fact, by rotating our fans and running the air across them, we could even possibly get rid of one or two and reduce both cost and weight. The only thing we'll need to do now is create a bracket inside of our assembly to hold the boards. And we'll start this simply by copying and pasting an existing surface. Now I can go through and create a new part in our assembly, as simple as that. But I'll want to run through several different concepts to see what may work better. Remember, I want to keep cost, weight, and size in mind. So first we can simply pull to thicken our surfaces into a solid. Remember, making changes in SpaceClaim is as easy as selecting on the geometry to make an edit. Whether you're pulling on faces, whether you're pulling on edges, or whether you're adding more detail to the part. SpaceClaim is a tool that new users, or even power users, can operate in order to quickly make their design changes. And if we want to have our holes on both sides of the model, simply copy them. No need to add a new feature, duplicate anything. All of the intelligence lives inside the geometry. But one thing we may want to do in our design is create an angled face. This will help air flow from our power supply model through vent holes in the top of our assembly. And this is a quick concept we've added with our angled face, but we may want to add some material data and take a mass calculation. I can see it's going to be almost 2 pounds for a bracket if this were to be machined. So I may want to experiment with shelling this out, adding a different thickness, and changing the material again. Instead of being steel, what if we made this out of plastic and took another mass calculation? I can see it's a lot lighter, the volume's less, but we'll ask a few vendors what they think. And in the meantime, I can experiment with a third option. We've seen a machine part. We've seen what our estimate would be for a plastic shelled part. But now let's look at possibilities for sheet metal. SpaceClaim allows you to take designs and convert them to sheet metal, add any bends or rips that are necessary, or even use our pull and move tools to create new walls. The same tools that you've seen in 3D modeling also work for sheet metal in the same easy-to-use fashion. Whether you're pulling to add new walls, modifying the thickness, or even adding forms to your part, simply change a few values for the form and then add that onto your model. But instead of having one, let's make a quick copy of this so we can see how this will affect airflow. Having 1, having 3, or even copying this to make 6. Being able to change your design on the fly several different ways allows people to make as many iterations and really funnel down to the best design possible. We can even unfold this and send this out to Machine Shop for a quick prototype. After we've decided on our final project, we may want to document this a little bit. In our drawing sheet, we can quickly lay out some of the key dimensions. I like to think of this as my engineering notebook, where for presentations I'll lay out a few quick dimensions, calling upon the size, the height, or the new lengths of our part, and even add a few quick notes. I may want to point out that I've reduced the weight by removing 2 of our fans and showing where those were. But another way to really present what you've done to the design and how you've changed it is to make a beautiful rendering. And in SpaceClaim, we can apply materials to parts and render them inside of KeyShot. KeyShot is our photorealistic rendering partner. It lets you add materials and environments to parts, and it renders them in real time. You can see the ray tracing happening before your eyes. With several different environments to choose from, you can quickly make your parts look as realistic as possible as soon as you think them. Let's review what we've done today. We've changed our layout and reduced the number of fans, and also added in custom brackets. This meets our new weight requirements, and we've also talked to our vendors about our new power supply for the box. And we've ended with both a 3D model for our proposal and also a beautiful rendering. So I hope you've seen how bid modeling can vastly improve your proposal process and help you win new business.